Once again, welcome back, our dear candidates. In the previous session, we talked about eclipses, the different types of eclipses, how they are formed, and the bodies or the features involved in eclipses. In this session, we're going to talk about reflection of light. You remember, as I was introducing this lesson about light, I said reflection of light enables us to see objects. How? Because light from them is reflected into our eyes. So, reflection is the bouncing back of light when it falls on a plain, shiny surface. Dear candidates, even if you said a reflection is the bouncing back of light, that would be okay. But if you want to be comprehensive enough, then you can add when it falls on a plain, shiny surface. We have different types of reflection, and these include regular reflection, then irregular or diffuse reflection. To begin with regular reflection, this is a type of reflection where a parallel beam of light bounces back in a definite direction as shown in the diagram. You have a ray of light striking the surface, which we've said it is shiny. In this case, regular reflection takes place on a shiny, smooth surface, preferably a mirror. So you can see that the rays are reflected uniformly. You can use the word uniform direction instead of definite direction. Then too, in the irregular reflection, here we're saying it's a type of reflection where a parallel beam of light bounces off in different directions. And this type of reflection takes place or occurs on a shiny, rough surface. And that's why it gives or it produces what we call irregular reflection, or what we said can as well be termed as diffuse. So, point to note, which I've just talked about, that irregular reflection occurs on a shiny, rough surface. Remember, regular, we said it occurs or it takes place on a shiny, smooth surface. I've given an example of a mirror. We have the law of reflection, and it is summarized by this diagram, which is having the incident ray, then it has the normal ray, the reflected ray, then we have these four angles. There is an angle which I've named G, there is an angle which I've named I, R, and G again. Then there is this point which I've named O. So we are saying that the incident ray is that ray which strikes the reflecting surface. In this case, we are saying that we can use a plane mirror to act as a reflecting surface. Then we have this line that is perpendicular to the surface to the reflecting surface, and this line is the normal ray or the normal line. Then we have the angle which I talked about, the angle between the normal and the incident ray, which is the angle of incidence. Candidates, do not confuse incident and incidence. This is a ray that is striking the surface of the mirror. Then angle of incidence is the angle between the normal and the incident ray. This angle here, which I've named angle I. Then the ray which bounces off the reflecting surface. We're talking about this ray which leaves this point, and we're calling it the reflected ray. The ray which bounces off. The ray leaving the reflecting surface. Then we have the angle which is between the reflected ray and the normal, angle R, and we call it the angle of reflection. Then we have angle G here and angle G there, and this is called the glancing angle. Maybe what I did not capture here is point O. Point O is the point of incidence. Where the incident ray, the normal ray, and the reflected ray lie. We call it point of incidence. Dear candidates, you're encouraged to stay home, stay safe by sanitizing, washing hands regularly with clean water and soap, because we need you alive and we love you. You'll do an activity on page 110 in your workbooks. Stay blessed.